Welcome to the video for C5.1.1. So this is going to be split into two parts. So part one is going to look at limiting reactants. I've put on there the links to previous knowledge. So things that tie in with this topic are interpreting chemical formulae, being able to balance equations, being aware of the conservation of mass. So the mass of the reactant is always equal to the mass of the products, and to be aware of what a mole is. So if you're not sure about any of those things, it's worth looking back in your textbook to have a remind yourself. So our learning objectives for today, we need to be able to state what a limiting reactant is, be able to identify a limiting reactant, and then use limiting reagents to work out how much product will be made. So I've used the word reactant and reagent there interchangeably. You can use either. So in any reaction, the limiting reactant is the one that gets used up. So if you're reacting two or more substances, one of those will get used up before the other one, because you never put exactly the same amount of both reactants in, and by amount I mean moles. So one of them gets used up first, we call that the limiting reactant. The other one, there's some left over after the reaction is finished, and that we call the reactant or the reagent that's in excess, because there's more of it than you need for the reaction. So we're going to look at a model for a limiting reactant, and like most of my models, this is to do with food. So I want you to imagine that you're making cheese on toast. So if you're making cheese on toast, you take one slice of cheese, and we're assuming that we've got those plasticky slices of cheese, so it's not proper cheese cut up into slices. Otherwise, it makes it more complicated. So I've got one piece of plasticky tasting cheese. I've got one slice of bread. To make my slice of cheese on toast, I put both of those together, I slap it under the grill, and then it's ready to eat. So the limiting reagent's the one that limits how much products are made. So if I have one slice of cheese and one slice of bread, then I've got my slice of cheese on toast. So if I had 3 slices of cheese and 4 slices of bread, then we need to look at what the limiting reactant in it is in this case. And hopefully it's obvious that because I've only got 3 slices of cheese, I can only make 3 slices of cheese on toast. So my slices of cheese are the limiting reactant in this case. So there's less of it than there is the bread. And because one slice of cheese makes one slice of cheese on toast, I will be able to make 3 slices of cheese on toast. If I look at the next example, if I've got 6 slices of cheese and 4 slices of bread, then because I use 1 slice of cheese and 1 slice of bread to make my product, we're just looking for the smallest number here. So the smallest number is the bread for 4. So therefore, my bread in this case is the limiting reactant. And because I've got 4 slices of bread, I can make 4 slices of cheese on toast. So that's a really simple example. We're going to make it slightly more complicated now, because I don't want cheese on toast. Now I want a cheese sandwich. And if I want to make a cheese sandwich, I use 1 slice of cheese and 2 slices of bread to make my 1 cheese sandwich. So in this case, it's a bit more complicated. I can't just look at the smallest number, because I need 1 slice of cheese for every 2 slices of bread. So if I now have 3 slices of cheese and 4 slices of bread, in the previous example, the cheese was the limiting reactant. But to make 3 cheese sandwiches, I need 3 slices of cheese and 6 slices of bread. So therefore, there's not enough slices of bread to use up all that cheese. So the bread is my limiting reagent in this case, because 4 slices of bread is only going to make 4 divided by 2. It's only going to make 2 cheese sandwiches. And my next example, sorry, I've gone too quick on there. If I've got 6 slices of cheese and 6 slices of bread, again, my bread is the limiting factor, because if I've got 6 slices of bread, that will only make 3 cheese sandwiches, whereas 6 slices of cheese would make me 6. So my bread is the limiting reactant there. So, as I said, 4 slices of bread is going to make me 2 cheese sandwiches. 6 slices of bread, 6 divided by 2, is going to make me 3 cheese sandwiches. So we're looking at the ratio between the bread and the cheese sandwiches. So if I've got 6 slices of bread, I need to divide that by 2 to work out how many cheese sandwiches I can make. So that's our model for it. We're going to look at some chemistry examples now. So this is a real chemistry example of limiting reagents. So if I look at my chemical equation here, I've got carbon plus oxygen to give carbon dioxide. And I've chosen this because it's a 1-to-1 ratio. So it's the simplest example that you're going to get. So first thing we need to do is work out the ratio in the equation. So in the box, you can see, if we look at the numbers in front of the chemical equation, it's 1 atom of carbon reacts with 1 molecule of oxygen to give 1 molecule of carbon dioxide. So it's 1 of each to make 1 product. So it's nice and simple. And I'm just like my cheese on toast, I'm just looking for the smallest number. So if I look at 3 atoms of carbon and 4 molecules of oxygen, because it's 1-to-1, we can clearly see that the carbon is going to be my limiting reactant. So I'm going to have carbon as a limiting reactant because there's only 3 atoms of that. And because 1 atom of carbon makes 1 molecule of carbon dioxide, that's going to make 3 molecules of carbon dioxide. Sorry, I've gone too quick again on this. So 6 atoms of carbon and 4 molecules of oxygen. Again, because it's a 1-to-1 ratio, we're just looking for the smallest number of either carbon atoms or molecules of oxygen. So the smallest number is 4. So in that case, the oxygen is my limiting reactant. And because 1 carbon makes 1 carbon dioxide, 3 atoms of carbon is going to make 3 molecules of carbon dioxide. And likewise, 4 molecules of oxygen is going to make 4 molecules of carbon dioxide. Okay, so that's the simplest example. We're going to look at a slightly more complicated one here. So this is more analogous with our cheese sandwich, because if you look at that chemical equation, so 1 oxygen molecule reacts with 2 hydrogen molecules to make 2 molecules of water. So it's not quite the same as a cheese sandwich because we only made 1 cheese sandwich and now we're making 2 molecules of water. So first thing I'll do is work out the ratio in the equation. So if you look in the box, 1 molecule of oxygen, 2 molecules of hydrogen to give 2 molecules of water. So if I now look at my molecules of oxygen and my molecules of hydrogen, so if this was like the previous example, I'd just be looking for the smallest number. So we'd say it was oxygen. However, because we need twice as much hydrogen as oxygen, 3 molecules of oxygen would actually need 3 times 2, need 6 molecules of hydrogen. So in this case, the hydrogen is the limiting reagent because 4 molecules of hydrogen is only going to need 2 molecules of oxygen. So we'll have excess of the oxygen. In the second example, so I've got 4 molecules of oxygen and 6 molecules of hydrogen. So again, oxygen is the smallest number. It's tempting to say that, but 4 molecules of oxygen would need twice as much hydrogen. So it would need 8 molecules of hydrogen. And there's less than that. So therefore, again, hydrogen is the limiting factor. So hydrogen is a limiting reactant or reagent. And in terms of how much they make, so 2 molecules of hydrogen makes 2 molecules of water. So 4 molecules of hydrogen is going to make 4 molecules of water. And 2 molecules of hydrogen makes the same number of molecules of water again. So therefore, 6 molecules of hydrogen is going to make 6 molecules of water. Okay, so there's our examples that we've gone through. So first task I want you to do is answer this exam question. So magnesium is a limiting reactant in this reaction. What is meant by the limiting reactant? So you need to pause the video here and write your answer down, and then the answer will be on the next slide. So there's 2 possibilities we could have written here. We could have written the reactant that's not in excess, or the better answer is to say that it's the reactant that is all used up at the end of the reaction. Right, second task you need to do is complete the questions on the worksheet. There is an extension worksheet available if you want to have a go at that. And then I've put on the box what you need to remember in terms of we need to work out the ratio in the equation. We then need to circle the limiting reactant or reagent, and then we use the limiting reactant or reagent to work out how much product is made. All you need to do now is answer the quiz questions. Okay, thank you for listening. See you next time.